This is Mr. Ward, and I'm going to do a video now on graphing inequalities involving standard form. And I'm just going to do videos on intercept form and slope intercept form and standard form. Intercept form is going to follow similar procedures, so will point slope form, but the testing out will just involve slope intercept and standard form. Since those are going to be the things you'll be dealing with in the next unit on equations primarily. But you can apply all these same principles there. So first thing you need to do is, we'll deal with this first one, 3x plus 4y is less than 24. First thing you need to do is graph a boundary line for your inequality. And to do that, you're going to need a couple of points. The good thing about the standard form is that you can get a couple of points by finding the X and Y-intercepts. So the X-intercept will be what X is if Y is 0. So when y is 0, we do not care about 4y because that becomes 4 times 0. So to find the x-intercept, we just say 3x. I'll go ahead and put the 4 times 0, but you don't need to. We're going to treat this as an equation right now because we're trying to actually solve a value. Okay, I meant to say 4 there. But as you can see, I don't care about 4y if y is 0. So I'm just caring about 3x equals 24. So x will equal 8. So I will have an x-intercept at 8, 0. Now, let's find 8, 0. I'll use this one for that. So we'll move this up to the x-axis since it's the x-intercept, and we'll put it at the x value of 8. And there it is. Now let's find the y-intercept. Y-intercept, it's the same basic procedure. In this case, x becomes 0, so we figure out what y is. So if x is 0, we do not care about 3x. 3 times 0 plus 4y. And we're going to treat it as an equation, so we can solve it. We don't care about 3 times 0. We just care about 4y. And so 4y equals 24. Y is going to be 6. So you're going to have a y-intercept at 0, 6. So let's make a y-intercept at 0, 6. And we'll move this point over here. There you go. Now you've got 2 points, and we can draw a line through it. Okay, let's figure out, do we need a solid line or a dashed line? Hopefully you decided it was a dashed line because it's not or equal to. The line itself is a set of points that's a boundary, but is not a set of points that is included in the inequality. Okay. There we go. There is our boundary, and now we just had to figure out which side are we going to shade. So we look at all the points we could test. We could pick any point here to figure out if it makes the inequality true. And unless 0, 0 is a point on the boundary line, I'm always going to pick 0, 0 because I try to make my math easy. Okay, and if I do 3 times 0 for x is 0 plus 4 times y is 0, since x and y are 0 at the origin, is less than 24, that becomes 0 is less than 24. And is that true? It's totally true. So I'll use arrows this time. So foomp, that side right there, that side is shaded. And so that side is true. Okay, if I had changed that inequality to greater than, then this would be greater than, and this would be greater than. So now I'd be saying 0 is greater than 24, and I would no longer be shading that side. I would now be shading this side, because 0, 0 would be a fail in that situation. And so everything on this side isn't invited. If 0, 0 doesn't get invited, nothing on that side is invited. And the only things that are invited are this side of the inequality. Not even the line is invited in this inequality unless I made it or equal to, in which case the line is totally invited. in which case we would make it solid. And there we go. Solid, and that side is invited. Okay, let's take a look at another one. And this one's slightly trickier. We need to once again work. Let me go over here actually and undo some stuff. So now we're going to work out this one. This one's going to be trickier because one of the points is, one of the intercepts is not as neat and tidy. So we're going to work out what the X and Y intercepts would be of the boundary line. When I do the boundary line, I'm going to treat that as an equation. So let me copy that, paste it, and make that equal. And to find out the X-intercept, I make Y equal to 0. So Y becomes 0, and we don't care about that. So it becomes just 5x is equal to negative 30. So x is equal to negative 6. So we would have a y-intercept at negative 6, comma 0. So let's move the x-intercept over there to negative 6, comma 0. There it is. Now we need to find the y-intercept. The y-intercept is going to be messier, as you might be able to see in the y. So I'm going to turn that to a y and make the x into a 0 to find the y-intercept. So I don't care about 5 times 0. So I'm going to be left with negative 8y equals negative 30. So y will equal negative 30 over negative 8, which is this 3 3/4. Okay, I'm going to simplify that to 4 and the 15. And the negatives actually go away because it's negative divided by negative. So it's 3 3/4, 3.75. So we could kind of graph it, you know, y-intercept at a little less than 4. So maybe that would work. But we can find more precise points by using the slope. So the slope of this is going to be negative a over b, and a is 5 and b is negative 8. So we can find the slope as negative 5 over negative 8. And since they're both negative, that means the slope is 5/8. And you can already tell the slope is positive because it's going up to the right. So that means that we're going to find another point that's up 5 and over 8 from negative 6, 0. So let's type in negative 6, comma 0. And we're going to add 5 to the y, because that's the vertical change. And we'll add 8 to the x. And so negative 6 plus 8 is negative 2. 0 plus 5 is 5. So there's another point at negative 2, 5. So let's actually find that. Negative 2, 5. So let's go there. Negative 2, 5. A little suspicious of this. I'm wondering if I made a mistake somewhere here. So 5 over 8, negative 6, 0 was my x-intercept. We'll find out in a second. Okay, so it's a slope of 5 over 8. So up, oh, I see the problem. I totally see the problem. Okay, so negative 5, sorry, 5 over 8. So that's going to be negative 6, comma 0. I'm going to add 8. Oh, that's right. So I'm adding 8 to 6. So that becomes negative. Oh, that becomes positive 2. That's the issue. Okay, some of you sitting in the bleachers are like, hey, Mr. Ward, negative 6 plus 8 is not negative 2. You were right. It's positive 2. So here we go. And I made a mistake. You make mistakes. It's a normal thing. Then we can figure it out. The reason I was suspicious of it was I had a y-intercept at 3.75, but I'm getting this point up here, which means my line goes like this, and there's no way it's going through 3.75. So I'm going to adjust that. Okay, so the y value is going to be 5 plus 0, so that's 2, 5. So we're going to move that over. That should end up, that point right there is going to end up here at 2, 5. Okay, and that makes sense for 3.75. Okay, so let's go ahead and move the line like that. Okay. I think I adjust it a little bit. As I get closer, I can see I'm not properly lined up with them. Let's move up. Almost there. Move it down a hair and adjust this up. And now down a hair. And now I've got my line. And look, it does go through about 3.75. So that's good. And now I just got to figure out two things. Is it dashed? And which side do let me find my actual equation. There it is. 5x minus 8y is actually an inequality, is greater than negative 30. So is it dashed? It's dashed because it's not or equal to. And then I'm going to pick a test point. Since 0, 0 is not on the line boundary, I'm going to use 0, 0. So 5 times 0 minus 8 times 0 is greater than negative 30. And is that true? So that's 0 minus 0. So that 0 is greater than negative 30. That means that 0, 0 is a winner. And so we will plot some sort of notes to show that this side, oh, I should have actually made those. I didn't realize they were going to be so big. I'll do that. Now that's interesting. Undo. Make that one solid. You have to troubleshoot from time to time. But this side is the side that's shaded. So you put some arrows on the side that's shaded. Everything in that direction forever is shaded. Everything up to this line, you can get as close as you want on this side of this line with, as long as you don't touch it. I think you get even closer, infinitely. Everything on this side will be included, but the line itself is not invited to the party, and no one on this side is invited to the party. So to recap, to find an inequality graph from a standard form, plot the intercepts, draw a line through it, decide whether it's dashed or solid. If it's or equal to it, solid. And then pick a point, a test point that would work. 0, 0 almost always works. If the line is going to the origin, then 1, 0 or 0, 1 will work. Okay, so you pick something easy, plug it in, and see if it remains true. In this case, it remained true. So that's good. If one of the intercepts is not neat and tidy for plotting, you have the option of plotting whichever one is easier to plot, and then finding the slope. The slope will be negative a over b in the standard form. All right, I hope that helped, and I'm going to stop.